Hi, in the last session, we understand RS-232 protocol and we learned about the standard baud rates as well. Now we are going to design this baud clock generator in VHDL for our UART project. So let's understand how we will design this baud clock generator for our project. And this is very important that we generate pulses at correct timings when you are transmitting or receiving any bit over the RS-232 protocol. So this is a simple block diagram that what we are designing here. We have this baud clock as an output here. Inside this module, we have a counter. This is named as bit period counter and it will increment at every rising edge of clock cycle, which is 50 megahertz suppose. Now we will compare this counter value with this bit period. This bit period is fixed for a specific baud rate, or you can say it is a constant value. Now, when our bit period counter value is equal to this bit period value, then we will trigger our baud pulse. And we will also reset our bit period counter to 0 to count another bit period for the next pulse. So this will happen again and again until all the bits are transmitted, right? And each time it will generate a pulse at this output baud clock. And the timings of this pulse will be controlled by this constant value, bit period. But here is a small problem that if we design the system, it will generate pulses all the time, despite we are sending data or not. And we do not want this. What we want that we want to generate only fixed number of pulses when we are transmitting data or receiving data. So we need some extra control signals for that. So what we need to tell that how many pulses we actually need for transmitting or receiving data. Now let's stick on the transmission of data first. Now for this purpose, we will create a clock counter like here, and it will count each generated pulse. We also need a trigger signal. For example, here we have start signal. Means when this start signal is asserted, we will load number of pulses to this clock counter. For example, we need 10 clock pulses. So when you assert this start signal, then this clock counter will load 10 as a counter value. And now as soon as a new pulse is generated from this baud clock, we will reduce one pulse from this value. So at the starting, it will say 10 pulses are needed. Then your first pulse will generate at this baud clock and it will decrease this counter by value of 1. And now you have 9 pulses remaining. Now second pulse is generated at this baud clock. So your clock counter will decrement by 1 again. So it becomes 8 now. Basically, it is telling that how many pulses are remaining to generate. Okay, so we need to ensure that when this counter is 0, means we do not need any more pulses at this baud clock output. We should stop generating pulses at this baud clock output, right? So we need this additional check here that we will only count bit period clock when our remaining pulses are greater than 0. Means this whole module will only work when you need pulses for transmitting of data. And for ideal time, it will not generate baud clocks. Now it looks little complicated. So let's brief it quickly. Let's consider that we are needing 10 pulses at baud clock when we start this module. So first we will trigger this start signal. When this start signal is asserted, then this clock counter will get 10 pulses, right? Because we will load value 10 in this counter. Now this value is greater than 0. So this bit period counter will count every clock signal. And once it matches to the specified bit period, it will generate first baud clock pulse. And your first bit will start transfer, okay? Now at the same time, it will decrease this clock counter value by -1. Means it is 9 now. Again, it is greater than 0. So this bit period counter will count for next pulse. and it will generate second pulse at this baud clock output, and also it will decrease this clock counter by 1. So now it is 8. Now this will happen 10 times, and when it will generate last pulse, this clock counter value become 0. Means now this condition is not met. So your bit period counter stops counting and no more pulse will generate at this baud clock generator. So this is the whole process. Now if you want to transmit another byte, then again you will trigger this start signal here and the whole process will run again. Okay, so if this is clear, then please try to design this in VHDL. If not, don't worry, we will be designing this in VHDL in the next session. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to Learn and Grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.